All right, let's continue on with number 12. So now I'm taking a cube root. Well, you can't take the square root of a negative number. I can take the cube root of a negative number because if you take negative 2 times negative 2 times negative 2, negative times another negative equals a negative number. So you can take the cube root of a negative number and you get a negative number. Uh, this will work anytime your index is an odd number. You can't take the square root of a negative number. You would get an imaginary number, and we aren't dealing with imaginaries right now. All right, so the cube root of 64. The cube root of negative 64, I do know is negative 4. So I'm going to take the cube root of that. This negative outside, that is a coefficient. So you can think of that as a negative 1. And this is a multiplication problem. This says negative 1 times this radical. So whatever numbers and letters I pull out from under here, these are going to end up being multiplied together. So this is this negative. The cube root of negative 64 is negative 4. Now let's deal with a to the 11th. So 11 divided by 3. So 3 goes into 11 3 times with 2 left over. So whatever this whole number portion is, that tells you how many of the variables get to come out. And whatever your remainder is, that is how many are staying inside. And then b to the 16th. So I have 16 divided by 3. 3 goes into 16 5 times with 1 left over. So that means 5 get to come out, and 1 is still staying in. Goodness. Negative 1 times negative 4. Let's see. I have 3 A's coming out and 5 B's coming out. And then what's still inside? An A squared and a B. So you could either leave it as B or B to the first, whichever one you want. So this is a multiplication problem. So now we're going to finish multiplying. That negative times negative is a positive 4. A to the third, B to the fifth. The cube root of A squared B. All right, so there's no index here. So there's an implied 2. So I'm looking for perfect squares. So I know that 300 I can break down into 100 times 3 because 100 is a perfect square. So I want to find the biggest perfect squares I can. A to the fifth, B to the fourth, C to the second. All right, so the square root of 100 is 10, so that is coming out from the radical. That 3 is going to stay where it is. A to the fifth. So 5 divided by 2 is 2 with 1 left over. So 2 A's are going to stay out, and 1's going to come in. b to the 4th. So 4 divided by 2 equals 2. So they're all coming out. I didn't have a remainder. And then c squared, 2 divided by 2 equals 1. So one of them gets to come out. All right, so I have an a squared coming out. I have a b squared coming out. And a c coming out. And then what is left under the radical? 3a. You have to finish simplifying this, and so this is a multiplication problem. So we're going to finish multiplying the 3 and the 10 and get 30a squared b squared c radical 3a. And then our last one is a cube root. So I need perfect cubes. When I did this a minute ago, I remember that 5 cubed is 125, so that's my perfect cube. And so 250 is 125 times 2. All right, so I have x squared. So 2 divided by 3, nope, that one is staying right where it is because my index, this exponent is smaller than the index, so that's going to stay. Y to the 9th. So I have 9 divided by 3 equals 3. So all the y's are going to come out. And z to the 10th. So 10 divided by 3 is 3 with 1 left over. So 3 of them get to come out, and that 1 is staying in. So the square root of the 125 portion is 5. What else is coming out? Some y's and 3 z's. So I have a 2x squared z still under the radical. I'm going to finish this off by multiplying these two and get negative 10 y squared z cubed, the cube root of 2x squared z. So anytime that you have an index other than 2, you do need to make sure you write it down. And that is how you simplify radicals.